So here are several examples that have you find other trig function values based on a given trig function value, and you're restricted to a certain quadrant on the coordinate plane. So for the first two, we're going to stay in between 0 and pi over 2, which is another way to say first quadrant. So everything is positive, x values, y values, everything is positive. So the sine of the angle being 1/3 is not a sine value that comes from the unit circle. None of the angles have a y-coordinate of 1/3. So we'll actually draw this in a unit circle, or in a circle. And because we're restricted to quadrant 1, in fact, I might make that a little more zoomed in here. We're only looking in quadrant 1 at our circle. So arbitrary angle with a point on the circle with theta coming from the origin, you can drop and create a right triangle here and then use the fact that the sine of that angle is 1/3. In chapter 8, when we did right triangle trig, the sine ratio was opposite over hypotenuse. So in reference to this angle theta, we're able to put the opposite value as 1 and the hypotenuse is 3. And if we can find this adjacent piece, then we'll be able to give the secant and the tangent values. So if we do Pythagorean theorem for 1 squared plus whatever our leg is squared equals 3 squared, we get 1 plus our missing side squared equals 9, our missing side squared equals 8, and so our missing side on the x-axis is the square root of 8. So that goes here on the x-axis for our adjacent piece. So then if we want to find secant of theta, secant, if you recall, will flip cosine, which cosine is adjacent over hypotenuse. So if we flip that, we'll put hypotenuse over adjacent. And in reference to this triangle that we've created in quadrant 1, the hypotenuse is 3 and the adjacent is the square root of 8. So you can put 3 square root of 8, or if you'd like to rationalize it, you can do 3 square root of 8 over 8. Those are both acceptable answers. For the tangent function here, tangent ratio, if you recall, is opposite over adjacent. So in the right triangle that we've drawn, the opposite side is 1. So tangent of theta. The opposite side is 1, and the adjacent side is square root of 8. So you can put 1 over square root of 8 or square root of 8 over 8, which is what it would be rationalized. So there's your two trig function values based on the one that was given. All right. Next one gives us that the secant of theta is 17. So we're in quadrant 1. So I'll draw sort of like a zoomed in arbitrary angle. Again, we're not trying to draw this to scale, but we do need to create our right triangle down to the x-axis. Now secant from before flips the cosine ratio. So instead of adjacent over hypotenuse, the 17 is representing hypotenuse over adjacent. Since we have a whole number, we can throw the 17 over 1. So we can label 17 on our hypotenuse and 1 on our adjacent leg. So we'll use Pythagorean theorem to find our opposite leg. So we have 1 squared plus the other leg squared equals 17 squared. So 1 plus the missing leg squared equals 2, I think it's 89. Yeah. And subtracting 1, we get 288. So our other leg is the square root of 288. So now we have our adjacent side. So we can come over here and it asks us for the sine of theta. Or I'm sorry, we have our opposite side. 288 is the opposite. And again, we're in quadrant 1, everything's positive. So sine ratio in a right triangle is opposite over hypotenuse. So in using what we found, we put square root of 288 over 17, and that's your sine value. Tangent ratio in a right triangle, again, which we've created in quadrant 1, is opposite over adjacent. So in reference to that angle theta that we put at the origin, we get square root of 288 over 1, which will just be the square root of 288 for the tangent of theta. Okay, so those are two examples in quadrant 1. When you start moving the angle to different quadrants, it will affect the x and the y coordinates. Okay, so please note that the hypotenuse is always positive whenever you do any of these. but when you start moving into quadrants 2, 3, and 4, the x and the y values can change. So for this problem, we're given that the cosine of alpha is the square root of 3 over 5, but alpha is now in the fourth quadrant. So I'm going to draw a zoomed in fourth quadrant. Again, arbitrary angle, but now that we're in the fourth quadrant, we have to drop, alpha will live here at the origin in our reference angle, but when we create our right triangle, it's always a right triangle in a reference angle. So we'll drop it to the x-axis, whether that's down or up. And so there's where our triangle lives. The cosine ratio that we're given, cosine is adjacent over hypotenuse. So the hypotenuse is 5, and the adjacent leg here on the x-axis is the square root of 3. Now in quadrant 4, if you remember the coordinate points, x value is positive, but the y value is negative. So we'll use Pythagorean theorem to get this missing side. But when we do so, the answer will be negative because it's representing a y value in the fourth quadrant. So we'll have to make it negative. So square root of 3 squared plus b squared equals 5 squared. So we get 3 plus b squared equals 25. B squared equals 22. And b equals the square root of 22. So that's our missing side, but we'll have to make it negative because we're in the fourth quadrant. I mean, when you take the square, you get plus or minus anyway, but specifically, we have to keep the square root of 22 negative because we're in the fourth quadrant. So when you go to answer questions like, what is the sine of alpha? That's the ratio of opposite over hypotenuse. So in reference to alpha from the origin, we get negative square root of 22 over 5 as our sine ratio. And for tangent of alpha, again, it's in reference to the alpha at the origin. It's opposite over adjacent, and that's the square root of 22 over the square root of 3. And there are a couple ways you could look at simplifying that. You can leave it like that. It does give a decimal answer, or it ends up being the square root of 66 over 3 if you rationalize it. But either way, you end up getting the same answer, so it's just all in the way that you want to represent it. But those are the sine and tangent function values based on the given cosine value in the fourth quadrant. Right, here's one in the third quadrant. So I'll bring up our picture and I'll draw sort of a zoomed in third quadrant so we can see it a little better. All right, again, arbitrary angle, but it's always going to be a reference angle. So beta is this reference angle coming from the origin. If I created a right triangle, it would drop it to the x-axis just like a reference angle does. And there's our right triangle. We're given the tangent ratio is 4 over 3. Tangent is opposite over adjacent. So if you remember, in quadrant 3, both x and y coordinates are negative. So when I label this purple right triangle opposite over adjacent in reference to this beta, opposite is 4 and adjacent is 3. But because we're in third quadrant, I have to make both of those negative. It's not given to you in the ratio, but because we're in third quadrant, both of those have to be negative. And if you put negative 4 over negative 3, you'd get positive 4/3, so you wouldn't necessarily see it. But when you put it in the coordinate plane and draw out this triangle, you have to make them both negative. So solving Pythagorean theorem here, negative 3 squared plus negative 4 squared equals hypotenuse, 9 and 16. C ends up being 5. Exactly. This is a special right triangle. And then when you go to find the sine of beta, the sine ratio is opposite over hypotenuse. So in reference to, the angle beta that we marked here coming from the origin, opposite is negative 4 and hypotenuse is 5. So your ratio is negative 4/5. And cosine of beta, again, it's adjacent over hypotenuse. So in reference to angle beta, adjacent is negative 3, hypotenuse is 5, and your cosine ratio is negative 3 over 5. So again, it'll give you a ratio, but if it puts it in a quadrant other than quadrant 1, you need to understand where it's going to live. Quadrant 2, for an arbitrary angle from the origin, the right triangle would come down. Okay? Quadrant 3, like we just did, angle will come from the origin, but the right triangle will go up to the x-axis. And in quadrant 4, it comes out, but it still goes up to the x-axis, and the angle comes from the origin. So you have to understand the orientation of those triangles with the reference angle, the way that reference angles always go to the x-axis, so the triangle always gets dropped to the x-axis to be able to come up with the right ratio for sides.